this, and they do pretty well on it. There's always a few that have a little bit of trouble, and it's not easy at first, but most of the time kids get it once we do these problems. So, example 5. The problem with example 5 is that on all the other problems, these easier problems, like this one, I squared both sides and it got rid of all the square roots. Here, I moved everything to the other side first. Then, whenever I raised both sides to the 4th power, the roots were gone. It worked really nicely. The problem with this is that this square root's already by itself, so I've got to square this side to get rid of it. But I've got to square this other side also. And on the other problems that we did when we squared both sides or raised both sides to a power, we just had a nice number there. We had to do like 4 to the 2nd power or negative 7 to the 2nd power. But here we've got 5 plus 2x. So there's some important things to remember. Number 1, 5 plus 2x squared is not 25 plus 4x squared. Okay? This, I'm going to write it, although I'm going to use the shortcut when I actually multiply it. 5 plus 2x. This is 5 plus 2x times 5 plus 2x. Alright, so, or, what I prefer is square, double, square. We practiced on that a little bit when we were doing those, completing the squares. So, square the first, you get 25. Multiply together, 5 times 2x is 10x. Double it, you get 20x. And square the last, so 4x squared. So when you square both sides, you've got to multiply that out there. So that gives you x squared minus 2x plus 1. So that gives you this, which almost looks worse, but at least it doesn't have a square root in it. So that makes it a little bit better. Okay, so questions? All right, what we have here is a quadratic. How do we solve a quadratic? Everything to one side, right? So subtract your x squared, add the 2x, and subtract the 1. And I'm going to put these x squareds first. So I got 3x squared plus 22x plus 24 equals 0. Alright, so you got a couple options on this. This one, because I already know what the answer is, this one actually will factor. But a lot of times when I see one like this, I just think to myself, oh, it just looks too bad to even try. I'm just going to use quadratic formula. So either one is fine here. In fact, I'm going to use quadratic formula because that is probably what I would do on this one. Instead of, because it's possible this doesn't factor, and then you would waste a lot of time trying to factor whenever it won't. So, and I think we could probably use a little extra practice on that simplifying, because I was noticing that a few of you were using quadratic formula on things that would simplify on the quiz, and you were kind of messing that up, and that is what got you the wrong answer. You got everything correct up until you start doing that quadratic formula. So let's just use quadratic formula here. So we've got x equals negative 22, assuming that this is calculator active, and it will be plus or minus the square root of 22 squared minus 4 times 3 times 24 all over 2 times 3. So let's grab the calculator. 22 squared minus 4 times 3 times 24 is going to give you 196. All over 6. And 196 we can take the square root of. we get 14. So here we'll have x equals negative 22 plus or minus 14 over 6. So x equals negative 22 plus 14 over 6, which is going to give us negative 8 over 6, which is negative 4/3. And x is going to equal negative 22 minus 14 over 6, which is going to give us negative 36 over 6, so negative 6. Okay, this would have factored. We could have done 3x and x and minus plus 8 minus 6. Does that work? No. Both of them need to be pluses. 8 and 18. No. This needs to be a 4. 24, yes. 4 and 18 would be 22. Yeah. So we could have factored it. It will factor. If you see how it factors, that's the quickest way to do the problem. But a lot of times I don't see it for this one. Now, for these problems, I stressed it, or at least I can't remember. I recorded those notes last year, so maybe I didn't stress it as much. But I did talk about extraneous solutions, right? So you got to check your answers. So extraneous solutions happen a lot with square root equations, especially whenever we get to the more complicated ones. I'm going to show you guys a calculator trick here. Okay? So you have to plug your answers back in to check to see that they work. So one thing that you can do, especially if you're trying to plug back in negative 4/3, that can get a little long and complicated even if you are using the calculator, and you might type your parentheses in wrong or something like that. So I'm going to show you guys how to store a number as a variable. Do you guys know how to do that? Okay, so x equals negative 4/3. So I'm going to type in negative 4 divided by 3. I'll hit enter. Now, this is the decimal for that. I could try to do this with negative 1.3 repeating. I could probably get pretty close if I tried. But if I do, right above your own button, you have a button that says STO and it has a little arrow. So if you click that button, it's going to say answer and it's going to put a little arrow. And then you can type whatever letter you want to let this equal. I'm just going to use an X. I used to tell kids not to use X because I thought it messed up your graphing, but it doesn't. It'll work just fine. So you can use X here. So what I've done right now is I have turned X into negative 1.33. So it has stored X as negative 1.3 repeating. So now if I type in 5 plus 2X, it's going to be 2.3 repeating. So it plugged it in for me. I didn't have to type it in. And I could type in the square root of x squared minus 2x plus 1. And I also get 2.3 repeating. So that tells me both sides of the equation are equal to each other. Here's what's really nice about this also. So that checks 4/3 works, or negative 4/3 works. That is one of my answers. Here's the really nice thing about doing it this way as well. Now what I'm going to do, my other answer is negative 6. So I'm going to do negative 6. I think I can do it this way. Negative 6 store x. So now it's going to replace that x with a negative 6 instead of that negative 4/3. If you press second enter, it'll bring up the last thing you typed in. And if you don't hit enter, if you keep pressing second enter, it'll give you the line before that. And if you press second enter again, it'll give you the line before that. So rather than having to type this back in, I can just hit enter. I get negative 7. if I do second enter, second enter, second enter, there's the other side that I want, and it's positive 7. So negative 7 does not equal positive 7, so negative 6 is not an answer. Okay. So what I was doing there is I wasn't writing it out, but I was just plugging in what I got for my answers. So like whenever which mom won't let me scroll up, I stored x is negative 6. So what I was really doing there was like I took 5 plus 2 times negative 6, which is 5 minus 12, which is negative 7, which is what I got for that side, right? And then I plugged in negative 6 over here, so negative 6 squared minus 2 times negative 6 plus 1. So that would be the square root of 36 plus 12 plus 1, which is the square root of 49, which is a positive 7. And that's what I got whenever I typed in this. So what the calculator does for you there is it just plugs in that value for you without you actually having to plug it in by hand. And so if you plug in one side of the equation and then the other side of the equation, you get the same number. So here, since you do not, then that tells you negative 6 is not an answer. Okay? You're welcome to plug them in by hand, but some kids like this shortcut here to sort of make it a little bit quicker. Because if you're like me, you really hate to do all the work on a long problem and then at the end still have to go back and do a lot more work to check your answers. So it makes it a little bit quicker. But on the quiz, there were many of you. I think it was number 3, maybe the third one in that column. But one of the answers did not work because it gave you a 0 in the denominator. A lot of you forgot to mark that answer off. I think it was 2, and a lot of you left it as an answer. But I don't think I took off a point for that. That does not happen that often with rational equations. You will get a lot of extraneous solutions with square root problems, especially the more complicated ones. So you really, really, really do always have to check your answers for those. And because it's more important to check your answers here, typically if you leave both answers, I'm going to count half off on those. So if they were worth 10 points, you get 5 points off. I'm not quite as strict on those rational equations because it doesn't happen nearly as often, but it happens a lot with these. So I'm going to count off more if you don't check. So make sure you check your answers. All right, here's your next one. So we have square root of 6x plus 12 equals 1 plus square root of 4x plus 9. Here you have a problem. You've got square roots on both sides, but you also have this plus 1 that's not underneath the square root. And here's where we run into major problems. Because I cannot put that 1 inside of the square root. If I subtract it over to the other side, it's still not going to go underneath the square root. So then I just have square root of 6x plus 12 minus 1. And then I've got something on the outside of the square root on the left side. So this is what we have to do for these problems. And I'm going to warn you, it's going to look worse before it gets any better. Okay, so we are going to square both sides. And so when we square the left-hand side, that's no big deal. The square root and the square cancel each other out. We get 6x plus 12. On the right-hand side, this is 1 plus the square root of 4x plus 9 times 1 plus the square root of 4x. is not 1 squared plus 4x plus 9. You can't just square the first, square the last. You're going to have to distribute here, which is where I'm saying it's going to look worse before it gets better. So 1 times 1 is going to give us 1. 1 times the square root of 4x plus 9 is going to give us, I'm going to write it this way, 1 times the square root of 4x plus 9, just because I think it clarifies things a little bit that I multiplied there. The 1 has to be on the outside. Square root of 4x plus 9 is on the inside, although that 1's not necessary. You don't have to write it. For the inner terms, I'm going to have another 1 times the square root of 4x plus 9. And then for the last terms, I'm doing square root of 4x plus 9 times square root of 4x plus 9. The square, or essentially what I'm doing is square root of 4x plus 9 squared. So here, I'll end up with 4x plus 9. And so this side is still 6x plus 12. Yes. Okay. So, you're saying to yourself, what is Mrs. Hyatt doing? This looks worse. It's terrible. And you're right, it does look awful. So, let's combine our like terms over here. Got, I could put that 1 and that 9 together here. So that 1 and the 9 is going to give me 10. I'm just going to go ahead and write that plus 4x to avoid dealing with those square roots till the very end. And then, so that was this one. Then I've got to put these two together. Whenever I add them, this is kind of like adding 1x and 2x. 1x and 1x, it would give you 2x, right? So 1 square root of 4x plus 9 plus 1 square root of 4x plus 9 is going to give you 2 times the square root of 4x plus 9. Okay. So now, let's subtract this 10 over here. And let's subtract this 4x over here. So we can at least combine those terms. So we've got 2x plus 2 equals 2 times the square root of 4x plus 9. Okay, it's starting to look a little better. It's still not great. We still have a square root, but it's starting to look a little better. I need to get rid of that square root. In order to do that, I'm going to get rid of this 2 outside first. I'm going to divide that 2 off, which thankfully it goes into everything evenly. So I've got x plus 1 equals the square root of 4x plus 9. There are some times where that's not going to go evenly, and we'll do one of those in a minute where we can talk about what we can do there. Okay. All right, this is getting a little bit more manageable. So I'm going to square both sides to get rid of the square root. And this time the square root will actually go away. So we will have 4x plus 9 on that right-hand side. On the left-hand side, remember that that is x plus 1 times x plus 1, so you have to square, double, square. So you'll get x squared plus 2x plus 1. All right, we've almost made it. We have a quadratic here. Elena, how do we solve a quadratic? All right, the first thing we got to do when we're solving a quadratic, what is it, Richard? It's got to be set equal to 0, so we got to move everything to one side. So we're going to subtract our 4x, and we're going to subtract our 9, because a quadratic has to be equal to 0 before you can factor or do quadratic formula or complete square, any of those things. So we've got x squared minus 2x minus 8 equals 0. Whew. Alright, so now this will factor, and this one's not too hard to factor, so I'm going to factor this one. So x minus 4, x plus 2. So I'm going to get x equals 4 as one of my answers, and x equals negative 2 as one of my answers. And we have to check it, because there's a pretty good chance that one of those is not right. And the reason is because when you square both sides of an equation, for example, if I say x squared equals negative 25 or negative 2, that can't happen. When you square something, it can't be negative. I'm sorry. If I take, let me do that. If I have the square root of x equals negative 2, that can't happen, right? When you take square root of something, it's got to be positive. If you square both sides, so you're going to get x equals 4. So it creates a lot of solutions that don't work. So let's check this. What do we get? 4 and negative 2. So I'm going to do 4 store as x. And then so I'm going to do square root of 6x plus 12. That gives me 6. And I'm going to do 1 plus the square root of 4x plus 9. And that's going to give me 6. So 4 works whenever I plug it in. And then I've got negative 2. So I'm going to do negative 2 store as my x. And I'm going to do second, enter, second, enter, second, enter. I get 0. If I do second, enter, second, enter, I get 2. So I get 0 and 2 whenever I plug in negative 2. Those two sides do not equal, so negative 2 is not an answer. Look at all that. It's a beautiful problem right there. Okay, here's our next one. Okay, so let's just look at this one and think through it for a minute, so don't write down what I'm about to do. So I've got square roots on both sides, or I got a square root only on the right side. If I square this is going to be the square root of 4 minus r plus the square root of r plus 1 times the square root of 4 minus r plus the square root of r plus 1. It will not get rid of the square roots because of that plus sign in between. So then you're going to have to do distribute. You get 4 minus r. Here you're going to get like the square root of 4 minus r times r plus 1. And then the next one you get the same thing. And the last one you get plus r plus 1. And you end up with like a quadratic underneath your square root. And I think it's just really difficult to do that whenever you've got the square roots in both places. So, what I tell students to do for these problems, it's not going to make it easy, but it might make it a little bit easier. Take one of these square roots and move it over to the other side. So, I'm just going to take this r plus 1 and I'm going to subtract that square root of r plus 1. Now you can write down what I'm writing because I'm going to do it correctly this time. So, 3 minus the square root of r plus 1 equals the square root of 4 minus r. And it really didn't matter which one I decided to move over to the left-hand side. But if you do this. Now when you square both sides, here you've got 3 minus the square root of r plus 1 times 3 minus the square root of r plus 1 equals 4 minus r. And so now whenever you multiply this, it's still long, but at least it's not quite as, you don't have everything under square root. So 3 times 3 is going to give you 9. 3 times negative square root of r plus 1 is going to give you minus 3 square root of r plus 1. The inner terms is going to give you the same thing. And then last, you're going to get plus r plus 1. You can use the square double square shortcut on this if you want. I just find that a lot of kids have a lot of trouble trying to square double square that in their head, so I don't usually do that. So we've got 9 minus 6 square root of r plus 1 plus r plus 1 equals 4 minus r. And so if we combine our like terms here, I can put this 9 and this 1 together. So I get negative 6 square root of r plus 1 plus r plus 10 equals 4 minus r. And then I need to try to get that square root by itself, so I'm going to subtract this r and subtract this 10. So I get negative 6 square root of r plus 1 equals 4. I'm supposed to cancel it. 4 minus 10 is going to be negative 6. Negative r minus r is negative 2r. Okay. Now on the last problem that we did, I divided off that number that was out front. You could also do that here. The only problem is that you're going to get a fraction if you do that. Negative 6 will go into negative 6 evenly, but it will not go into negative 2 evenly. So you can do it that way. However, I usually prefer to do this. I'm going to do this. I'm going to go ahead and square both sides, which seems wrong. But it is okay as long as I square the negative 6 and the r plus 1. So when I square the negative 6, I'm going to get 36. And then in these, I'm going to put in parentheses r plus 1. And then over here, I'm going to square, double square, so I'll get 36 plus negative 2 times negative 6 gives me positive 12. If I double it, I get 24r, and then square the last, positive 4r squared. The other option there was divide by the negative 6, and then you'd have to square negative 1 or positive 1 plus 1/3 r, so you'd have to FOIL with that fraction there, which will work. So we got 36r plus 36 equals 36 plus 24r plus 4r squared. Alright, we're down to a quadratic here. So let's move everything to one side. I'm going to subtract this 36R. I'm going to subtract the 36. So I get 0 on this side. I'm going to write that 4R squared first, minus 12R. And then my 36 actually cancels on both sides. How do I factor 4R squared minus 12R? What do I do, Alex? Pull out a 4R. So greatest common factor here. So 4R times R minus 3. So I will have 4R equals 0. So R equals 0. And I'll have R minus 3 equals 0. So R equals 3. Okay. Questions? And you're not done because you must check your answers. So obviously this just needs to equal 3. So I could do 0 store x. So I would have the square root of 4 minus x plus square root of x plus 1. Alright, so that gives me 3. 0 works. That's great. I'm going to store, I'm going to do, what's our other answer? 3. 3 store for x. And I can press second, enter, second, enter. Also 3. So both of these actually work. So, questions on that? Yes. So, in the calculator, one of the answers is 0. So, if you just press, now you are welcome, like it is perfectly acceptable. If you don't really like this shortcut, it is perfectly acceptable for you to just type in 4 minus 0 square root plus square root of 0 plus 1. And you get 3, and this is 3. That's fine. So if you don't like it, you don't have to use it. But if you do 0, and then you hit the store button, which is right above your own, and then you type the X, then you'll get 0. Although, I don't know if that calculator will do it there. So, and then you just type in the equation like it is. So square root of 4 minus X plus the square root of x plus 1. There. So that'll give you 3. And since the other side of the equation equals 3, then that's correct there. Does yours do it? Yeah, okay, good. So, and then the good thing about that is if you, I don't know if yours will do this, but if you store, all right, no, 3 store for x. If on mine, I'm not sure if that'll do it. If you press second enter and then second enter again, it brings back up what you just typed in, and then so you don't have to actually type it all in again to plug in 3. It does, yeah. Okay, so your assignment is going to be, where did I write it down there? Page 254. 15, 19 through 23, and 25 through 28. Actually, now I think there might be one I need to get started on. There. Let's look at 20 real quick. I just want to get you started on 20 because we didn't do one like this. This one, everything is under the square root. So you are not going to be able to avoid having to multiply something that's all square roots. But it would be a little easier if I took this square root of k and I added the square root of k over here. So I would have the square root of k plus 9 equals the square root of k plus the square root of 3. You can't make that the square root of k plus 3. It would be nice if you could, but you cannot. And then, when you square both sides of this, you've got square root of k plus the square root of 3 times square root of k plus the square root of 3. And so here, square root of k times square root of k is just k. When we multiply square root of k times square root of 3, both of those are underneath the square root, so we're going to get the square root of 3k. They'll have to both be under the square root. And then for the inner terms, we'll get another square root of 3k. And then for the last, we get a plus 3. Questions? I'm going to leave you there, see if you can finish this one. It will not. That's a good question. So, you'll have the k. You have this k. It's like you've got a 1 in front of both of these. That's why sometimes it's good to write the 1. So, you're just adding those two 1s together. So you'll have 2 times the square root of 3k. Like that. See if you can finish that one up.